Right. So my name is Jared from Shimadzu Scientific. Back there is Majed. He's your local service engineer. He's from Shimadzu as well, obviously. So this is your universal test frame. As its name implies, depending on the configuration, it can test a great many things. We're going to go over some of the basic features of the frame, change out the different configurations. Right now it's a tensile configuration. We're going to change to a compression configuration. You also have a lower capacity load cell as well, so we'll go through with the lower capacity load cell compression configuration as well, 3-point bending, and then finally a tension configuration for that. Over on the other frame is a torsional configuration as well. You have accessories to turn either frame. It's basically a duplicate setup, so you could have 2 torsion setups if you wanted to, or whatever kind of your workflow allows for. But again, if it were me, I would maybe kind of keep that one a torsional, and then kind of keep this one changing between tension, compression, and bending. That being said, if your workflow allows, 2 torsions, 2 compressions, whatever you guys want. And then after that, we'll go through a quick review of the software, do some Q&A. All right. And in addition to the compression tension, you also have a couple extensometers. You have an optical extensometer right here, and you also have a contacting extensometer, and we'll go through those too when we go through the software. All right. So some basic features of the frame. Some basic terminology if you're not familiar. Starting from the top to the bottom, the top that kind of connects the 2 columns together is called the yoke. This is the crosshead. This is actually what moves up and down. The bottom is the table. Between the crosshead and the table is usually where you fix your jigs, as they're referred to, depending on what type of testing you're doing. On the top here is the load cell. So this is what actually detects the load. Within these 2 ball screw columns right here are ball screws. So essentially they're screws that rotate around, causing the crosshead to move up and down. You have your power switch is on the bottom right here. In addition to the power switch, you have a breaker on the back, and that's made to kind of protect the instrument from power surges or anything like that. So if, for instance, you were to come in the morning, the instrument's not turning on, that's the first thing you would check. So there's a little warm-up period. So some safety features of the frame, you have limit switches, both top and bottom limit switches. And essentially the function of that is such that if the crosshead were to move down or up, either by you adjusting it manually or the program to be running, that these jigs, whether it's the compression plates, whether it's the tensile fixtures, or even the 3-point bending, they don't collide into each other. And essentially how it works is that you adjust them to the height that you want them. So for instance, we had a sample that we were going to have fixed in here. We'd have a certain height that these jigs would be apart. Set that certain height, move your limit switch up by rotating the limit switch, move it up a little beneath the crosshead, and then tighten it. So if I were to move the crosshead manually down, it would activate the alarm. In addition to the limit switches, you have these safety stops right here. If at any time you feel like something's going to collide or there's any danger to the instrument or person, please feel free to touch them. You're not going to damage anything by touching these. So to activate them, push in, rotate to deactivate, and sometimes either on the software or this touch panel, you usually have to clear the alarm. There's a few other safety features here. There are load limits that you can adjust in the software. There's also limits that detect rate of change called the touch load alarm. So if the force is ramping up at a certain level, it'll shut the instrument off. You can get a safety cover for this. That's not an option right now, but it is something that's available that through the course of running your samples, you see that being an issue. That's an option that you guys can employ. So as far as operating the frame right here, you have what's called a smart controller. So essentially what this is used for, manually operating the crosshead when you're placing your sample. So turn it into manual mode, go up or down for a higher speed jog, and also a jog wheel to do a lower speed jog. You can also zero the force and position from this controller as well. You can also stop and start a test. There are additional features down here that you guys don't need to worry about for additional equipment, such as automated grips or automated extensometers. It's something that you don't have an option for right now. In addition to that, I'll go over briefly is this touch panel controller. Right now it's just kind of giving you the live readouts of force and stroke. If you wanted to, you could also write a method with this, meaning the conditions that your test will be ran under. You can view graphs for previous tests. What I think we'll do is that we'll kind of go over the software on the computer after the hardware portion, and then maybe touch on this a little bit. This is nice from a standpoint of being able to operate tests from the frame, but when you're writing complex methods, the software is better. And if you kind of learn the software, this is really intuitive as well. So as soon as you learn the software, like I said, this is somewhat of an intuitive thing. Something I want to touch on real briefly. So you have multiple load cells, so this is important. And we'll go over this again when we swap the load cells from one to the other. So essentially,